Hello, students. In this session, we are going to learn about the types of DC generators. Let's get started. Types of DC generators. The magnetic field in a DC generator is usually produced by electromagnets, not permanent magnets. Generators are classified based on how the field is excited. DC generators are divided into two main types. 1. Separately excited DC generators. 2. Self-excited DC generators. The load behavior of a DC generator depends on the type of excitation. Separately excited DC generators. A DC generator whose field winding is powered by an external DC source, like a battery, is called a separately excited generator. The output voltage of this generator depends on the speed of rotation of the armature and the field current. The higher the speed and field current, the more EMF is generated. But these generators are rarely used in practice. Most DC generators are of the self-excited type. Here is the circuit diagram. Armature current, I is equal to IL. Terminal voltage, V equals EG minus IR. Electric power developed is EG into IA. Power delivered to load is IA multiplied by EG minus IR, which equals V into IA. Self-excited DC generators. A DC generator whose field winding gets current from its own output is called a self-excited generator. There are three types based on how the field winding is connected. 1. Series generator. 2. Shunt generator. 3. Compound generator. 1. Series generator. In this type, the field winding is connected in series with the armature winding. That means the entire armature current flows through the field and the load. Since it carries high current, the winding has few turns of thick wire with low resistance. These generators are rarely used, only for special applications like boosters. Circuit explanation. Power delivered to load is V into IL. 2. Shunt generator. In this type, the field winding is connected in parallel to the armature. That's why it's called a shunt generator. This field winding has many turns of fine wire and high resistance. Only a small part of the current flows through the field winding. The rest goes to the load. Let's see the details from the diagram. Right shunt field current, ISH is equal to V divided by RSH. Right armature current, I is equal to IL plus ISH. Right terminal voltage, V equals EG minus IR. Right power developed in the armature is EG into IA. Right power delivered to load is V into IL. 3. Compound generator. This is a combination of series and shunt generators. It has two field windings on each pole. One is connected in series. One is connected in parallel. Compound generators are of two types. A short shunt compound generator. Here, the shunt field winding is connected across the armature only, not across the series field. From the diagram, right series field current, ISE is equal to IL. Right shunt field current, ISH is equal to V plus ISE into RSE, divided by RSH. Right terminal voltage, V equals EG minus IR minus ISE RSE. Right power developed equals EG into IA. B. Long shunt compound generator. Here, the shunt field winding is connected across both the armature and series field. From the diagram, right series field current, ISE equals IA equals IL plus ISH. Right shunt field current, ISH equals V divided by RSH. Right terminal voltage equals EG minus IA times RA plus RSE. Right power developed equals EG into IA. Right power delivered to load equals V into IL. Pushpin note. In all cases, power loss due to resistance is I squared R. Voltage drop occurs in the armature and field winding. Efficiency depends on how much of the generated power reaches the load. Direct hit summary. Let's revise the key points quickly. Separately excited generator. Field winding uses an external source. Series generator, field in series with armature. Shunt generator, field in parallel with armature. Compound generator, uses both series and shunt fields. Woman teacher, that's all for this session on types of DC generators. I hope you understood the topic clearly. Like the video, share it with friends, and subscribe for more such lessons. Thank you so much.